Can you hear me? Is it picking up? All right. Well, welcome to the 2 o'clock presentation here. My name is Adam Compton. I'll be talking about a product, a tool I wrote in my spare time along with the co-developer of my... Take a step back. My name is Adam Compton. I'm here to present on automated pen testing toolkit, more on automating process for penetration testing, as well as a demo of a tool we worked on this year. My co-developer with me, Austin Lane, both of us work for Rapid7. We've been working on this as a side project this year outside of our standard duties. It's just one of those things that we both wanted to see something like this out there in the market that was a little more user-friendly and what have you, so we started working on it. Let's go ahead and jump in here a little bit. If I'm going too fast, I'm not talking loud enough, I'm going too slow, whatever, please raise your hand, let me know, shout at me, what have you. The obligatory, who am I? Father, pen tester, husband, programmer, hillbilly. So, standard thing. Born in the mountains of Appalachia, 40 plus years ago now. So, going on into it. A little bit of background, a little bit of preface here is, where did this come from? Well, I've been doing pen testing for, as I showed on the previous slide there, a number of years, a decade and a half to 2 decades going on now. And over time, you start to develop a standard process that you go through every time you're doing it. And I'm sure those of you who do pen testing or have done pen testing, you've had your own standard process. This is a somewhat generalized one. It's not as full-featured as what you would actually be doing, but the general flow of it is in here, and you'll see some similarity. Such as you would usually start off your penetration testing with something like recon and discovery of the network. You're going to find out what services and hosts are out there, things of that nature. Then you'll go from that to testing some of the low-hanging fruit, the simple services, FTP, things of that nature. You might try testing some default credentials. You're not sure if IPMI, Tomcat, JBoss, what have you. There's any number of services out there. You're going to try some default. You see a website, you might try admin, just things like that. Some of the more default creds that you're going to come across. Next one down the line is then common exploits. So, believe it or not, I still see MSO 8067 out there probably 4 times a year. And out of those 4 times, 3 of those times it actually works. And I still scratch my head every time I see this. But, so you're still going through this standard process. You're looking for these common things. There's nothing really innovative at this point. Next, you're going to go through, oops, I didn't mean to hit that. Next, you're going to go into, once you gather, in between common exploits and dump creds, there's that little fuzzy area. You're doing some of the more advanced stuff there, possibly. You might try some additional things. But like I said, this is a more generalized flow. You're getting into dumping credentials, information from systems. Once you start to get in a foothold, you're going to do dumping additional user lists, things of that nature, which follows immediately into the next one, which is rinse and repeat. Just use that to pivot and go forward and so forth. This is a general flow, and yes, I know there should be another one at the end, which is the dreaded report, but we're leaving that out of here. At no point am I hoping to actually automate a full report, so no. I'll let somebody else deal with that. That's too much of a headache as it is. But we'll use this as sort of the outline going forward as to the steps that are involved. So, wait a second. Did I jump one there? Yeah, well, I must have deleted a slide on accident. Well, we'll look at the great outline first. What are we going to be going over? Pen testing often begins with a simple routine, which we just saw. Next, this routine can be rather slow on large networks. On your smaller networks, say like a /C or a /24, Class C, something like that, you can go through this process fairly quickly. Unfortunately, here in the last couple of years, I've been doing pen tests, when I've been doing pen tests, they end up giving me like, oh yeah, there's only X number of systems you need to target. Well, great. What's the target range? It's this /8. I'm going, oh, that's fun. Thank you. Fine. So you start through the same process and try to enumerate, and it just takes a while. There's a lot of steps in there. Even if it's not like a /8, say it's like a fairly populated grouping of like 5 Class Cs. That's still a lot of systems in there, a lot of services you need to go through. And yes, it can be slightly time consuming. But don't worry, this can be automated. Well, anytime you have a standard routine that keeps coming back and back and you're doing the same thing over and over, there's a good chance you can automate some portion of that. Reason I'm more concerned with automation than probably some others is I come from a programming background. And I'm also lazy, so I don't like to repeat myself if I can help it. So any part of my daily routine I can automate, great. Writing scripts, as we saw here earlier with Python and Shell and all that. Anytime you can do something like that can help out, that's awesome. And there's any number of ways you can do it. Currently, you have Python and Bash and PowerShell or whatever your choice is. You can even go with something like C or C++ if you want to go like a full compiled language. And the process of all this ended up with Austin and I working on a side project and resulted in the automated pen testing toolkit. I think that's right. APT2. Yes, I know it's an odd acronym. It's the best one we could come up with. It's a lot better than the original one we were running with, which was Kitty, for Script Kitty. And since this was a company-sponsored side project, they didn't like having the idea of Script Kitties associated with Rapid7, so we went with APT2. Much better second choice there. We'll talk about a lot more of this. We'll see a demo of it in a little bit. Going back to the process a little bit, you're going to start out, you're going to run something like Nmap or port scanner of choice. Pretty much you're going to be running Nmap. I don't care if you're running your vulnerability scanning tool of choice, it's probably going to be running Nmap under the hood. So you're still running something like this. Once you get the results back, you're going to go through and review the ports that you found. Port 21, well, is there anonymous FTP on it? Or what kind of files are stored on there? You're looking for this sort of thing. Port 80, well, what kind of web service is it? Their default creds? Any number of things like that, and so forth. Can I enumerate users? And is there null sessions? Is there MSO 8067? You're going to go through this list, and it's going to potentially be a fairly long list you're going through if you're doing a full pen test, trying to find as many attack vectors as possible, give your customer the best result possible. Next, you're going to go into running, well, you might not do it next, but you're going to run it at some point in there. Run some more advanced tools such as Responder, CrackMapItZack, Metasploit, attack framework of choice in here. You're going to be looking for those other kind of common exploits that people have written tools for. If you're fairly more advanced, you might be running some of your own in-house tools or exploits you have in there, but you're going to be going through this sort of next step through here. At some point during this process, you've gained access, you've got to the crown jewels of whatever the engagement was after. It's the medical records, it's the credit card numbers, it's their sensitive, proprietary chicken soup recipe, whatever the case is. You've got there, you've taken it over, you've grabbed the databases, and game over. But you're still going to go through this standard process. It works, but if it works, why am I concerned about trying to do something about it? As I said before, one is I like to automate things where I can. But in addition to that, automation helps in multiple ways. One, if I go up against the customer today, and then I come back and do it 6 months from now, I might not be thinking the same as I was today. I might not be have the same setup as I do right now. I might, or even two coworkers running on the same engagement or a little bit apart. You might not have the same tool set or the same background. So you like to use this tool, I like to use this one. There's a level of consistency in there from the customer's perspective. So the customer comes back, well, he found this, why didn't you find this? Or so back and forth. You can repeat the same testing over and over. Anything that's automated, anything that is scripted, you tend to have that level of consistency going forward. Even if you make changes to the automation, you still have the majority of the consistency is being passed along. No real issue there. And in addition, as we well know, humans are prone to mistakes. You might leave out a particular subnet range when you're doing your scan. You might forget to run a particular tool on a particular target. You might forget to check for weak passwords until Friday of an engagement, and you find a credential then that would have saved you a lot of time up front on the rest of the engagement. Things like this, that you might do things out of order and all that. Scripting, tools, all this stuff kind of helps with that. It helps build that consistent baseline as you go through. It helps repeatability and so forth. So, as I say, using tools on this, great. Why not use your insert giant tool of choice here, automated tool of choice, whether it's Nexpose or some other vulnerability scanning tool. Well, valid point. By all means, if you have those tools, definitely make use of them, use them. Any tool that you can run is always going to help out. There's plenty of them out there. They're very useful in some scenarios. There's any number of web app scanning tools out there. Run those against your web apps, database scanning tools, general vulnerability scanning tools. All these have their definite place in network security. And they can be adapted for use in consultancies and doing penetration testing and things of that nature. And some are open source, so they're fairly cheap. Not all, but some are. But at the same time, they can be fairly expensive. Some of them can be rather expensive, some of them not so much. Some of them can be fairly resource intensive. I know some of these vulnerability tools and what have you, when you go to load them on your system, they require, as a baseline, something like 8 gig of RAM. That's pretty intense. If I'm going to be installing it on my base OS, fine, but many times I install this as a VM, and that's a lot of resource to allocate to one VM or into a virtual private server or something like that. So you have that to concern about. And ultimately, down here, if you see that you have your tool of choice, you're running it, and you're like, wow, this is great. I want to add, I wish it would do this extra little thing over here, or I wish it would do this a little differently. With the exception of one or two little tools out there, as a whole, it's very hard to get that added into these larger commercial tools, things of that nature, because they are, well, commercial, or they're in-house, private code base and things of that nature. Now, there are a few out there that are out on GitHub and these places, which makes it a little easier. But as a whole, that's not the case. So you end up submitting a request, a issue ticket, or a request feature, or a feature request, and it might take 6 months before that gets implemented. And thus, well, let me take a step back. And that's why I wanted to go down this path of writing this tool of, it's a simple automation, which, first and foremost, I'm not looking to automate the entire process. I'm writing a tool that which helps the flow of the engagement, helps you get a good foothold going. But I'm looking to make it to satisfy a lot of this. It's going to be cheap. It is, well, fairly minimal resources, and it's fairly easily extendable, more so than the many other tools that are out there. If you have a little bit of programming background, we'll get to. So you can automate a lot of your standard tasks, whether it's Nmap, it's running Metasploit, it's running CrackMap@Zec, Responder, all this. All of these are tools that are out there that you can automate. Whether it's through Bash or Python, Metasploit even has its own RPC. There's beef hooks that you can use, beef API hooks that you can use. So much of what we do as a penetration tester, it can be automated. It not necessarily is easy in some cases. Sometimes the output of these tools give you some raw data that isn't easily parsed, but there again, if you're willing to write a little bit of scripting to parse that data, to make use of it, it's a few regex statements, you can make use of it and go forward. And so we get into APT, APT2. It handles all of this in the form of three basic modules. Three basic components. A set of modules which do various actions we'll talk about. An event queue which helps it decide when to run these various actions or modules. And a knowledge base to store everything in the background to make decisions. It can do everything from, it starts with running nmap, taking the output of nmap, hopefully in the future using additional input tools, things of this nature, whether it's from Burp Suite or insert tool of choice as an input, whatever you have as your at your facility. It will take that set of data that it gets as an input. It builds a set of events off of it. These events might be things of the nature of an IP was found, a particular service was found, a domain name was found, any kind of little thing that it might use as a trigger for something else to be keyed off of. It then goes and takes each one of those events, pops it off, and hands it off to the appropriate module or modules. Each module has within it a set of metadata that says, I can handle any event of this type, which, for example, there might be one that is check for anonymous FTP. And its trigger, its event it's listening for is port 21 is found open. So it says, okay, fine. It takes that, pops it off the queue, hands it off to that module, it goes and processes. And continues down the path. Modules can create their own events. So, speaking of that one, event was created at the beginning, port 21 was found open, hands off to the anonymous FTP module, anonymous FTP gets it, goes through, says, hey, yeah, you really have anonymous FTP on here. It triggers a new event, adds it to the queue, or creates a new one, adds it to the queue, which is called anonymous FTP, with associated IP in there. So that now, when that gets popped off the queue, it's looking for any other modules that can handle anonymous FTP is actually found on a system, and that module would be executing and running. It makes a little more sense when you see the demo in just a moment. I do apologize. It is a little abstract at this point. In this process, this adding things to the queue, taking things off the queue, running modules, adding back to the queue, keeps processing and processing until eventually that queue drops down to 0. All modules finish. At that point, there's no other actions that can be performed, and it terminates, generating some level of post-analysis, reporting, if you will. I hate to use the term reporting, but some level of post-processing there. Why is this better than the standard way? First and foremost, it's consistent. Secondly, it is rather faster than doing it by hand. It does it in a multi-threaded fashion. It runs it as fast as, well, it can run them, as well as there is a slight timeout in there, or a sleep command or something like. There is a slight pause in between the commands to throttle across the network, I should say. It does run multi-thread. I think by default it runs 20 threads in parallel. That is configurable in the config file. And if you're running on Kali Linux at the moment, it is fairly straightforward to get running on there. You clone the Git repo, and there's 3 or 4 different modules that have to be, or Python libraries that need to be installed. Once that's done, it'll continue on. Now, one thing to be said is the modules are fairly atomic and standalone. When the tool runs, if a particular requirement for a particular module isn't found present, it doesn't crash the entire tool. It gives you an output, a little red line at the top that says, sorry, we could not load module XYZ because it is missing the following dependency. But everything else will continue to run. Granted, if you want to have the full functionality, you'll want to go install that dependency. A dependency could be anything from a Python library to a command on the system, such as, well, going back to one of the other ones, responder. If you don't have a responder installed on your system, the responder module obviously can't run because it's not present. It'll tell you it can't run because required tool responder not present. So, I advise you to go do it. So what can it do? It can identify services and operating systems. It can screenshot web applications, X11, VNC, any of these remote interaction services. If it finds a way to access a FTP, NFS, SMB share, any sort of these remote network shares, if it can access it through anonymous connections or through guessable credentials or gathered credentials somewhere down the path, it will try to analyze those, search through them for sensitive file names. Right now it's just searching for file names, but that could be extended easily to search for file contents. Taking a little longer, obviously, or possibly incorporate some other tools in there in the process. If it finds systems, it can try to brute force some default credentials. It tries default credentials, but if default credentials don't work and the severity and a certain flag is set, it can start to brute force those accounts off of a provided dictionary that you provide for it. If there is a particular Metasploit module that might be relevant in a particular situation, it can call out to that and run that as well and take the output of it. If it captures hashes, so forth, everything you can see here. Basically, if there is a command line tool in Linux that you make use of, you can write a module for it. Modules consist of a little bit of metadata and a function to run the command and process the output of that command. I'm not trying to recreate, or we're not trying to recreate all of these functions, all these tools. They're great tools. There's lots and lots of tools out there people have written. We just want to make use of it and then figure out ways to chain them together to make them flow logically. Speaking of a module, everything that APT2 does is built around this module concept. As I said before, APT2 is an event engine, a knowledge base, and a whole suite of modules. There's 3 types of modules: input module, action module, and report module. An input module, all it does is, at the very beginning, when you first start up the tool, any input files you provided, it takes those and applies it to any input module, sees if it can process that kind of input. If so, it builds initial event queue. Action modules are the part that do all the other work, and then when that finishes, you have the report module that says, all right, everything else is done. Let's go and look at all that gathered data, all the findings, and try to put some order to it. Right now, there's only one input module, and that's for Nmap. There's only one report module that puts out a sample little generic web report, which is there as a placeholder for people just to see that that's how it can be done a little bit. But it's completely open as to what kind of report you want to create, things of that nature. It's just a matter of doing queries to the knowledge base and generating whatever output you want, CSV or PDF if you want, or whatever output you want. That's on you to figure that out. But all the data is already there for you to digest. Action modules, the meat of it, are the part where I said that does all the actual meat of the application. They inherit from a parent class, in this case, action module. And there's the metadata part of it, the header part, which has the tool name or the module name, a description of it, what requirements it needs, such as it needs Nmap or it needs RPC info or RPC client or something like that, whatever tools are necessary for it. Trigger, what events is this listening for? It could be listening for one or more events, such as it might be listening for port FTP or port 21, either one. Could be listening for a web one, port web or HTTP, HTTPS, 80, any number of ones you want to put in there for it to trigger off of. Safety level is a very important one. For those of you who are familiar with Metasploit and Metasploit safety levels or certainty levels, where it goes excellent, good, and so forth, great. Similar thing here. A scale of 1 to 5, 5 being this module shouldn't have any impact on your network. It's purely information gathering. That's where most of your Nmap Nmap modules are going to fall in, or something that goes out and connects to web services just to get like this server banner off of it. Something like that. That's going to be a 5. All the way down, next down, you'd have things that would go out and do some sort of interaction back and forth, maybe testing for default credentials, something of that nature that still shouldn't cause anything bad on your network, but it's interacting with a service at that point. 3 on down, 4 is your, 3 and 4 is where you're going to get more of your little a little more interesting modules in there. You're going to start doing some brute force attacks in there, things of that nature. And one is going to be something where it's like, yeah, I wouldn't recommend you run any of the safety level 1 modules on a production network, because odds are that's probably going to crash something. Currently, we don't have any modules of safety level 1. The lowest we have is a 2, and that is password guessing, brute forcing. So I don't know what we'd actually label as a 1 at the moment, but we don't have any in there at the moment. Maybe in the future, but as of right now, no. Are there any limitations to what can be made as a module? Yes, the tool, as of right now, anything that you create a module around needs to be non-interactive. If it's a tool that you have to run that is waiting for some input at some point that you have to hit enter, as of right now in the form of the framework we have, that doesn't work well. It has to be fully unmanned, run it and walk away and it runs. Now, that's not to say in the future we don't have a way to handle that, or if you're wanting to try to contribute to it and contribute something that can handle that, great, we'll run with it and go forward, but as of right now it needs to be non-interactive. Multi-threading can be tricky. One produces a lot of traffic, but other ones are such as a responder. You don't want to kick off 3 instances of a responder at once. Some modules can be threaded out to ever how many instances need to be running, such as we can kick off 5 different null session SMB null session checks at one time, no problem, against different targets. But responder, you only ever want to have like 1 instance of that running at a time. So each module has a way to throttle that. You can say that this module can only have 1 or 2 or 3 instances running, or if you leave it alone, it will run as many as it needs to get the job done. And anytime you're brute forcing something, be aware that this does have a likelihood to lock out accounts. It's just your standard generic warning. If you're going to do something that's a little dangerous, consider your safety ratings to adjust that. That is, if you're writing a module. If you're running this, there again, consider the safety ratings, the safety levels. By default, I think we go at a level 4, but on most engagements that I've used it, I tend to set it at about a 3. Just, I know the tools, I know what it can do. You know your environment better. And run at a high level and step down if you want to. Also, in the current implementation, things that are running on non-standard ports might throw it off a little bit. For example, you have FTP running on port 9000 for some reason. Nmap scans it, doesn't get a good feel on it for coming back. It might be a custom written FTP service or something like that. So it doesn't register, it doesn't fingerprint as FTP. So it's not going to see it as FTP. The tool isn't. As a result, anything that should be triggered by that isn't going to be triggered. But for the most part, we are not seeing that happen. Nmap has been around for God knows how long now, and it's really, really good at fingerprinting services, as well as the other tools that are running are really good at fingerprinting it. We're not seeing that actually present an issue yet, but that scenario does exist that it could. So let's just do a quick run through some numbers here, just ballpark figures, baseline, and then we'll jump into the demo. Let's say you have 30 servers with FTP. You want to test each one for anonymous FTP. You're probably going to spend about 10 seconds per server to test it, manually type it in, figure out what's there. So you're looking at, that's a little bit on the long side, but still you're looking at a couple minutes to check them all. You're going through, having to log into each one, might fat finger a command every once in a while, so you have to try it again, wait for connections, all. So you're looking at a couple minutes at minimum. Running it through the same module to check that through APT, you're looking at about a second per server because of the way threading works. Since automated, it can type a lot faster than you can. You're still looking at under a minute for it to do all of that. And that's even on a conservative scale there. A little more accurate than that is, this is something that I've done in the past, is you run Nmap, you get the GNmap output, you're wanting to say, all right, go through and grep for port 80 open out of that, grep for the second field, put it into an IP list. So here's all my port 80 systems. All right, I got that. Now I have to find what tool I want to run against it. SSL scan, eyewitness, whatever. Run the tool against that IP. If that tool allows multiple file of input, great. But many times it's a one-to-one, so you have to run it for every IP. If you need to look it up on a help menu or something like that, the particular syntax, if you haven't run it in a while, so forth, it's adding up time. Repeat for each service you're looking at, whether it's now web, it's SMB, it's FTP, same thing as we said before. Now keep in mind that while you're doing all of these one at a time for each different service even, APT2 can be doing all that at one time because of the way multi-threading happens. And at the same time, if it does miss one at this point because it doesn't have that data, at some other point down the road, an event might happen that says, hey, we found that data now. It'll go back and rerun against that one with that data to get full coverage. So ultimately, APT2 doesn't do anything that you don't. It just shortens that initial time frame for you. The goal of what we were working on with this, I'll let it get started. Let me see if I can jump over to it. No? Oh. Let me jump back then. Why aren't you jumping over? Hello? Why won't you switch over? I don't know why that's still up. Quick time. Quick. That's really weird. Why are you still up? Alright, just a second while I'm trying to figure out why PowerPoint won't switch off. Alright, let's go over here. Where are you at? Alright, just a second. Die already. I'm not sure why PowerPoint has decided to not die. There. Alright, die now. Let's go back up. Close you out. Alright, don't save. Alright, video time now. What? Alright, just a second. Everything got messed up somehow. Where are you at? There we go. Alright. Try this again. For some reason it wasn't wanting to play. And you're still not wanting to. There you go. Alright. So, when you go and first go and clone this from the Git repo, you'll see a directory much as this. Not a lot in there. You'll have the APT2 binary Python script, a config file, the modules directory, and a few other little bits and pieces in there. We'll step through this as I'm talking over it as well. What I'm saying might not actually map up to this, but pay attention to whichever one you want, honestly. The video is actually out on the GitHub repo if you want to see it there later on. It will be in this video as well. If you look at the config file, in there, there's the connection strings for MSF, paths for tools that it doesn't understand, that might not be known. And you are running mighty fast. So, you look at the help menu on here. A few things to notice. You do have the -S for safety level. Exclude types. That's a new feature that's been added in here recently, and that is every module has a default type, and you can specify that in the module, such as brute forcing, password cracking, web. So you can say, I don't want to run any web-based attacks, so you can exclude it there, specify the config file. Okay, well now you're going to take your time. So be it. So clear the screen. We're going to run it first time and see what kind of output we get. First thing you see is that it says it could not connect to the Metasploit MSG RPC service. I use MSG RPC to communicate with Metasploit back and forth, so there has to be that service started up. It even tells you the command that you want to use. Once you get into MSF console, you'll want to run this command based on the parameters that were in the config file to sync up the communication. Let's go ahead. Get this off screen. Give it a second. We're going to copy that over. All right, so now that's loaded up. So next time we run this, it's going to actually be able to connect up. We're going to go ahead and run this with some of the more common options that I would typically use, such as the -VV, which is very verbose, going into debug. -S, I'm giving it safety level 1. -B to bypass the menu. There is an interactive menu if you want to run it that way, which pauses in every step. Typically, I just do the -B to disable that, just do the whole wrong code thing, set it and forget it, come back and look at it in a little while. Provided an input file. This is one I ran against my local hacknet I have, local.xml. Going a step back there. This is one of those things that I want to make clear is this is not designed to replace a pen tester. It's there to replace that first day of your work that you're doing, which is that repetitive stuff you're doing. Like I said, it's that port scanning, that default services, all that stuff. It's checking that stuff. If you have some sweet sauce, awesome sauce that you want to go in there and do extra stuff with, this isn't going to do that unless you choose to write a module for it, and then it might be able to do that. And there's some advanced things in here that it's a little hard for this to do that we haven't got coded up, such as SMB Relay X or something like that. So in order for that to work, you have to have a system to use as the target to hand off to, which is something that you're probably going to, as a human brain looking at it, you're going to make that determination. It's hard to automate that decision making. We're working on it, but that's proving to be a little bit more difficult than I had initially thought. But this is definitely a time saver and a definite help. I definitely run it on every internal engagement I have. Right there, you see a particular module is disabled. In this case, I manually disabled it, but if there was a particular reason, it would have said that. As you're going down, you'll see a lot of output scrolling because I have the debug enabled at the moment. Some of the stuff you'll see on here, it tells you every time a particular module is running, what it's doing. It's getting a screenshot. It found an IP on a particular work group. It's going through, just doing a bunch of little things. Nothing very important yet. Give it a little bit here. Okay, first thing, it found anytime there's something in red in the output, that is something that is of a more critical level that you need to take note of. It might be a finding, it might be an error or something like that. You definitely need to look at the reds. In this case, it's saying that null sessions were found on a particular IP. That's great because that's going to trigger other modules that are relying upon null sessions being present. Let it run on down through here a little bit. You see a couple more showing up and down here. It was able to connect up, grab work groups, domains, things of that nature. Let it run a little further on. All these null sessions. Okay, we found our first instance of another finding of MSO8067. While it says that MSO8067 was found here, that was a little bit of a misnomer. I probably should correct that in the code. But what that's saying is that the nmap host vuln, or there's a particular NASL script for nmap that says check for MSO8067. That's what that did. That's saying that nmap thinks it's there. Now it's going to kick off a Metasploit module for that to try to actually exploit that in a moment. Let's keep going. Okay, right here. every 30 seconds or so, it outputs this line here telling you what the active threads are. It's sort of that I'm still running, I'm still doing things output, just to give you an idea. And what the event queue is. At this time, there's 12 items in the event that haven't been triggered or that haven't been launched yet. That's grabbing local user information. It's running Hydra against several systems now. Lots of output going on. It'll be done here in just a second on this. And now we're letting it finish up down here at the end. And one thing you notice down here, there's a number of interpreter sessions that are created in there, mostly from the MSO 8067, but anything else that can create an interpreter session is triggered down here as well. In this particular demo, I know it was 08067 as well as PSExec is what triggered these. And you can interact with the interpreter as normal. It's all there. Fun and happy games. This is finished up here. In doing so, you'll see that it says it created a report file there. That's, we might look at that in a moment, I believe. But now you have 3 additional directories created: log, proofs, and reports. Logs is where there's a file in there called processlog.txt, and it's an output. I think we look at that first. Yes. It is actually the full timestamped output of everything this tool did. As you can see, it's everything in there, so you can go back and trace through, see what happened at what time. Very handy in the, because of the threading, things kind of get jumbled around a little bit. It's the full output. You can look at that. Next, we're going to go into the proofs directory, which is where everything else is basically stored. Every time a particular tool is run, secret stump is run, RPC client, responder, all these tools, every time a tool is run by a module, it gets a file created. Regardless if it was successful in doing what it wanted to or not, there's a file created. So some of these files contain errors, or not necessarily errors, but 0 findings back. Some of them actually contain valid findings, things of that nature. It's all written into this directory so that you can go back and look at it manually if you wish later on down the road. Let's go ahead and look at a little bit of this. We're going to look at first secret stump, I believe. So nothing. And then there's all the output of that. At the same time, while these modules were running in the background, when it grabbed secret stump, it actually pulled this apart, dumped it into the knowledge base, and then that triggered additional modules to run to try to do like PSExec using pass the hash with those hashes across other Windows boxes on the domain to see if it could get access. If it did, it opened additional sessions and it continued down the path with that. So one thing that APT does well is it actually feeds upon itself. Unlike some of the other Pentest automation things that I've seen out there, which ultimately resulted in just really long sequential scripts that people have written with a little bit of logic in there, what this one does is that at the beginning of any time I run this on a new network, I don't know which modules are going to be run in what order and how many times. It's all dependent upon what data is found on that network. It'll take what data it finds, like there it found a JDO and password, in-body and password, and it's finding all this, throwing it back in the knowledge base, and then it creates new triggers off that, events to add to the queue, which then it gets popped off, gets launched against additional modules. So it keeps this process going, consuming and producing its own data until it runs out of things that it can process. Its only limitations are that it has to have data to consume, and it can't do anything that it doesn't have a module for. That second part is easily remedied if you're on a network that doesn't work. Figure out what does work and write that up as a new module, and we might get something moving there. And it helps out across the board. Output of all the Metasploit modules are in there, so forth. I don't know what we're looking at right now. Oh, yeah. Now we're looking at one of the standard reports, the one report module we have in there. Let's go ahead and look at it. Like I said, don't look at this report and go, oh my God, that's the best report they could create? No. It was one that we put together in a fairly short amount of time just as an example of what could be thrown in there. I mean, if you've ever looked at the web version of the Nmap output, it's basically that plus more. For every vulnerability, it shows you the raw data for it. It shows the attack vectors, things of that nature. That's something else. As it's going through each of these modules, it's maintaining the vector by which it got there. So that, for example, the full vector to something might be IP found, port 445 found on that IP, null sessions found, user list, user data, user enumeration, which led to password guessing, which led to MSF session, which led to secrets dump, which led to pass the hash. So it maintains this whole path as it goes through, so you can trace back through it and rebuild the entire attack vector if you want to provide that. And I think we're done. One of the other reasons why we have all that raw data in the proofs directory and not currently have a very extensive report module in there is that this isn't a full pen test. This is just a part of a pen test. It's something to ease your workload. It's the kind of stuff that saves you a couple hours, maybe a day of an engagement, more likely half a day of an engagement for one person. It goes through and automates a lot of that stuff. As more and more modules gets added in, it's going to automate more and more of that, obviously. But all that raw data is in there so that when you're writing up your report, I don't know how your reports are, but ours, when we do it, for each finding, we say, this is the title, description, affected host, and here's a proof of concept for it. And we tend to do screenshots and stuff like that in there. You have all the raw output of the commands and the tools up there, so you should be able to open up one of those, screenshot that, and dump it in directly. Okay, let's jump back over to PowerPoint now, if I can get my Mac to decide to work properly for me. Alright, let's go view. Jump back to where I was. Kind of crashed there. Alright, let me see, where are we? Alright. So, where is it being developed at? It's out on our GitHub page, Moose Dojo. That is the Rapid7's public ad hoc repo out there. It's not the Metasploit repo. It's not any of those. It's the one for the pen testers. Basically, say, we've been working on this side project and we want to host it somewhere, and they're like, here, host it here. So we put it up there, and this one's under Moose Dojo /APT2. What other future plans do we have for it? More input modules, more than Nmap. Hopefully, we're wanting to get several more in there, but right now that's it. Work out this process a little better. We currently have this working. Responder, John the Ripper, secrets dump. There's some other things in there that we want to tweak a little bit. We want to do lots more modules. Basically, anything that we typically do on an engagement, we want to write up a module for. We have a pretty good base in there with 41 modules right now. But every time we're doing an assessment, we're writing down, taking notes of, here's the commands we run, in the order we run them, so that we can go back later and say, how can we write modules for this? So we're working on that. We want to replicate other people's methodologies as well. This is basically the way that Austin and I approach it, so we're writing it up that way. Maybe port it to Python 3. Right now it's Python 2.7. We might make it Python 2.7/3 compatible. All depends. Maybe additional report modules, not sure. Ultimately, we're just going down our standard path of adding more modules and tweaking as we see fit, unless the community decides to give us a feature request or bug issues or something like that, then we address those as well. And for those of you who happen to be Python developers, take a look at it. See if you want to write your own module. If you have questions about it, reach out to us. Reach out to me. My info will be up in a moment. Speaking of which, I'm on Twitter as Titanus, my work and personal email, where you can find the repo at. I know I kind of went a little fast through there at points, and I got my laptop decided to break on me for a moment in there, but still, Does anybody have any questions? Something I might not have covered? Yes.
Is there a way that you could set it up to do like a break, like doing all the automated stuff, but not doing the auto interpreter sends to the system?
If you want to disable interaction with interpreter, you just don't start MSG RPC within interpreter, within Metasploit. And then it will run through everything else, and it'll make calls out to that and go, oh wait, on the first time it goes, oh, I can't connect, so it won't even try to connect to that in the future. But at that point though, anything that might be reliant upon some of the data that interpreter session could have gathered, you don't, because there's several modules in there currently that are, their trigger event is new session created. So, but that's fine, Yes, it will do that.
There are times where, like, I might not want to pop that.
Understood. Mm-hmm.
So your point's valid.
Yes. Right. But yes, you can do that. If you don't start the MSG RPC interface for Metasploit, then it won't run against it. But it will still run everything else up to that point. Anything that might be triggered based on that, no. But if there's another way to do those same triggers, then it will still do that. For example, just using crack map at ZEC or something like that, where it can issue and get some of that data, it might go down that path and do it. So that's one of the things is we're not trying to script up a linear path for this to do it. We're writing for every step. We might be writing like 2 or 3 different modules that might be able to process that data, might produce its own thing. So it's a whole web of things, so that if one doesn't work or you don't have this tool, then another one might be able to fill in that gap and go forward. So, any other questions? Yes.
You said maybe Python 3?
Maybe.
Why did start there?
Because over 80% of all Python projects on GitHub are currently Python 2.7. Going for market share. Honestly, that's why. And if you're going to install, if you have a Linux system that has Python on it, odds are it's going to have 2.7 before it will have 3. I've found some Linux distros that don't even have 3 on them yet, for whatever reason. So we went with market share. And that's it. That's the only reason.
I only asked because when you're looking at performance.
I understand, and that's right. The question for those who didn't hear was that why didn't I go with Python 3 initially? And it was just for market share and for the number of people who'd be readily able to use it. Yes, I know there's lots of both performance improvements as well as coding shortcuts I can use with 3 that I can't do with 2.7. That's why I said I might go down the path of making it 2/3 compatible, so I can have the best of both worlds. If you have 3, you get all the optimizations. If you have 2.7, at least it'll work. So forth. We are looking to completely revamp the backend knowledge base. We're working on we're trying to figure out what's the best way to handle that in a threaded environment for Python with concurrence that's going to be efficient. So we're trying to work out different models, different schemas, different databases. So we're still working through all that, testing a bunch of things out. Between that and possibly adding in Python 3, it should be a significant speed improvement.